In this video, we will be solving a few questions based on the Bayes theorem. To solve this type of problems, you don't have to memorize a formula or learn a concept. You only need to practice maybe 3-4 questions, and with a practice of just 3-4 questions, you will easily learn how to identify a problem based on this particular type. And if you have a practice of solving a few questions, you can easily solve all the questions by the same technique. Let's begin with the first question. I've taken these questions from the Maharashtra government textbook 11th standard maths part 1, and I have not solved all the questions in one particular sequence. Question number 1 and 4 from this particular exercise, I have solved them at the end of the video. So in case if anyone is referring questions along with the textbook, I've said that 1 and 4 is at the end of the video. For others who are referring questions along with me, here's the first question in front of you. So a box contains 2 blue and 3 pink balls. So 2 blue, 3 pink balls in one box, and there's another box containing 4 blue and 5 pink balls. So 4 blue and 5 pink balls. One ball is drawn at random from the two boxes and it is found to be pink. Now see, they have already told you that the ball selected is a pink ball. Okay, pink ball it is, and that is something that they have already said. You have to find the probability that it was drawn from the first box, and in the second case you need to find the probability that it was drawn from the second box. So if we talk about, let us say, box 1 or box 2. Now see, we are selecting one box at random. So what's the probability that box 1 is selected or box 2 is selected? Probability of box 1 or box 2 to be selected, they are equally likely to get selected, and that is why the probabilities of their selection are half. So P of box 1 or P of box 2, both of them are equal to half. We now go ahead with box 1. See, if I talk of a pink ball from box 1, if it is given that we are selecting box 1, then probability of getting a pink ball will be 3 by 5. So we say that probability of getting a pink ball, given that it is box 1 getting selected, that will be 3 by 5. In a similar way, if I give you that box 2 is selected, if it is told to you that box 2 has been selected, then given that box 2 is selected, the probability of getting a pink ball will be 5 by 9. So we will say P of getting a pink ball, given that box 2 is selected, that will be 5 upon 9. And now we go for answering their question. The ball is already found to be pink, that is, it is given that it is a pink ball. You need to find the probability that the box has been drawn from the first box. So to put it properly, you are finding the probability of box 1 given that it is a pink ball. Okay, so we are writing P of 1 given P. That's what we are trying to find in this question. Now P of 1 given P, ideally it is defined as P of 1 intersection P upon P of P. Now whatever you have been given over here, you need to write the reverse of it in the numerator right here. So we will say this is equal to P of, in the numerator, like I said, you need to write the reverse of this, that is, write P of P given 1. Now as per the definition of conditional probability, P of P given 1 is P of P intersection 1 upon P of 1, but we want only P of P intersection 1 or P of 1 intersection P, they mean one and the same. So in the numerator we want only P of 1 intersection P, but when we write P of P given 1, we are saying this is P of P intersection 1 upon P of 1. That upon P of 1, if you want to eliminate it, you can write it as into P of 1. So this P of 1 eliminates the P of 1 that appears in the denominator of this, and it leaves you with P of P intersection 1, which is what you precisely had in the numerator. So that's how we are rearranging our numerator. All you need to keep in mind is this, that whatever is your numerator has to be written as reverse of this. If you're finding P of A given B, you will write the numerator as P of B given A. Okay, and balance out the denominator by multiplying with the appropriate term here. In the denominator it is P of P. Now P of P means probability of getting a pink ball. How can you get a pink ball? Either you can get a pink ball with 1 getting selected, that is, you can get P of pink ball with 1 getting selected, or you can get a pink ball with the box 2 getting selected. Okay, so you can get a pink ball as P of P intersection 1, that is box 1 getting selected and you getting a pink ball, or means the plus sign, box 2 getting selected and a pink ball coming out, that is P of P intersection 2. And we will write P of P intersection 1 like we have written it in the numerator. So P of P intersection 1, we write it as P of P given 1 into P of 1. Similarly, P of P intersection 2 can be written as P of P given 2 into P of 2. We have framed our entire formula. All we need to do is put in the values and evaluate the final answer. So P of P given 1, it is 3 by 5. So in the numerator we have 3 by 5. P of 1, which is half. The denominator contains P of P given 1 into P of 1. That's 3 by 5 into 1 by 2 plus, check these numbers, P of P given 2, which is 5 by 9 into P of 2, which is 1 by 2. You can pull out a 1 by 2 common from the two terms in the denominator and cancel it with 1 by 2 that you have in the numerator. Let's rub out all these terms. So this is the entire thing that you're left with. 3 by 5 plus 5 by 9. That's 27 plus 25, which is 52 upon 45. So 52 stays in the denominator, 45 goes to the numerator. And this should give you 5 getting cancelled with a 45 here, giving you 9. Nothing else gets cancelled. So 27 upon 52 is the final answer for your question number 1. That is probability of the pink ball getting selected from box 1. That probability is 27 by 52. And then they are asking you what is the probability that it is selected from the second box. You can evaluate it in a similar way, that is P of 2 given P. But for all those who are little quick with this, you might have understood that P of 2 given P will be the same as 1 minus P of 1 given P. Think over it. You already know that it is a pink ball that has got selected. The pink ball is selected either from box 1 or from box 2. The probability that it was selected from box 1, that is 27 by 52. So the probability that it will get selected from box 2, it will be 1 minus this probability. So probability of 2 given pink, that will be 1 minus 27 by 52, which will be 25 by 52. Like I said, you can evaluate it by the same very method that we have discussed for P of 1 given P, and you will still get the same answer. Okay. So all the sums are going to be of this type only. The working mechanism remains the same. And like I said, with practicing of, with a thorough practice of just 2-3 questions, you can get a firm grip on this particular type of questions. Let's go ahead with the next question. It says that there's a working women's hostel in a town where 75% women are from the neighboring town. They've not written women, but it means women. 75% women are from the neighboring town. So 25% are from the hometown. The rest all are from the same town. Okay. 48% of women who hail from the same town are graduates, and 83% of women who have come from the neighboring town are also graduates. Find the probability that a woman selected at random is a graduate from the same town. Okay, let's first interpret the entire data and then we go for identifying what the question is. Probability of woman from a neighboring town is 75%, so let's call it 0.75, or okay, I'll write it as 0.75. Let's not deal in fractions for now. Probability of woman originating from the hometown, so it's 0.25, because out of 100%, if 75% are from the neighboring town, 25% are from the same town, that is hometown. So P of H is 0.25, and 48% who hail from the same town are graduates. So now, given that a woman is from the same town, the probability of that woman being a graduate is 0.48. So probability that a woman is a graduate, given that she belongs to hometown, that will be 0.48. And in a similar way, women who have come from the neighboring town, 83% of them are graduates. So given that the selected woman is from the neighboring town, if it is known that she is from a neighboring town, then the possibility that she is a graduate will be 0.83. So probability of graduate, given that she is from neighboring town, that will be 0.83. Now in this question, you are asked to find the probability that a woman selected at random is a graduate from the same town. So see, they are telling you that the woman selected is a graduate. Okay. Now, given that the woman selected is a graduate, what is the probability that she belongs to the same town? So you have to find the probability of a woman belonging to the hometown, given that she is a graduate. Okay, steps remain the same. This is probability of H intersection G upon P of G. P of H intersection G should be written as the reverse of this. Reverse of this. Reverse of this will be P of G intersection H. There's a denominator which is P of H in this term, and that P of H is not needed. So we multiply this with P of H, and that is how we are writing the numerator, which was P of G intersection H or P of H intersection G, whatever you call it, they mean one and the same. In the denominator it is P of G. Now what is the probability of getting a graduate woman? Probability of getting a graduate woman can be split in two parts. It is probability of getting a graduate woman from hometown or probability of a graduate woman being selected from the neighboring town. Okay, P of G intersection H, we write it exactly in the way we have written our numerator, that is P of G given H into P of H. The second term was P of G intersection N, and we write it as P of G given N into P of N. All we need to do is substitute the numbers now. So P of G given H is 0.48. So we have 0.48 multiplied by P of H. P of H is 0.25. I think it would be appropriate to write it as 1 by 4, because even in the denominator you will have similar numbers. P of G given H into P of H. That will again be 0.48 into 1 by 4 plus P of G given N, which is 0.83, into P of N, which is 0.75, which we will prefer to write as 3 by 4. If you multiply the numerator and denominator by 4, this term vanishes, and even here you will have 0.83 multiplied by 3. So 0.83 into 3 will be 2.49. 2.49 and 0.48, that's 2.57 and 2.97, right? Yeah, that's going to be 2.97. Now 0.48 upon 2.97, we can write it as 48 upon 297, and I guess we can cancel off a 3 in the numerator and denominator, so that should give us 16 here, and this will be 99. Okay, so it's 16 upon 99, and that's the probability of a woman selected at random to be a graduate from the same town. So that's how you are answering your second question. Let's go ahead with the next question. Jar 1 contains 5 white and 7 black balls. Again a similar question. So 5 white and 7 black balls. Jar 2 contains 3 white and 12 black balls. So that's your jar 2 containing 3 white and 12 black balls. Jar 1, jar 2. A fair coin is flipped. If it is a head, a ball will be drawn from jar 1, and if it is a tail, a ball will be drawn from jar 2. Now this is just a simple way of saying that probability of jar 1 to be selected or probability of jar 2 to be selected is going to be half. So you can say P of 1 equal to P of 2, and that will be equal to half. We continue with further part of the question. Suppose that the experiment is done and a white ball is drawn. Now see, they have told you that the ball being drawn is a white ball. What is the probability that this ball was in fact taken from jar 2? It is exactly like the first question that we had done, and that's the reason we will go a little fast with this question. Probability of getting a white ball, given that you are selecting jar 1. If you select jar 1, probability of getting a white ball is pi by 12, and probability of getting a white ball, given that you have selected jar 2, that's going to be 3 by 15. Or you can reduce it and write it as 1 by 5, that will do. Now with all that information, let's go for answering their question. They are asking us what is the probability that this ball was in fact taken from jar 2. So what you're trying to calculate over here is probability of 2 given that it is a white ball. See, they have already told you that a white ball has been selected. You only have to find the probability that it is getting selected from jar 2. That means you're finding P of 2 given W. P of 2 given W by definition is P of 2 intersection W divided by P of W. Like we have discussed, whatever is the numerator will be written in terms of reverse of this term. So you write the numerator as P of W given 2, and when you expand P of W given 2 it is going to give you P of W intersection 2 that you wanted, but divided by P of 2 will also be there, and to eliminate that divided by P of 2, you multiply this with P of 2, and that's how you write the numerator. Now in the denominator you have P of W. Probability of a white ball getting selected will be P of white ball getting selected along with box 1, that is P of W intersection 1, or you can have a white ball with the box 2 getting selected, that is P of W intersection 2. P of W intersection 1 being written as P of W given 1 into P of 1 plus P of W given 2 into P of 2. We are writing P of W intersection 2 as P of W given 2 into P of 2. Now, if you start substituting the values and try to evaluate, you will get the final answer. So P of W given 2, that's 1 by 5. P of 2, that's half, divided by P of W given 1, which is 5 by 12, into half, plus P of W given 2, which is 1 by 5 into half. So you can pull out this half common from the two terms in the denominator, cancel it with the half that you have in the numerator. So you have 1 by 5 upon 5 by 12 plus 1 by 5. 5 by 12 plus 1 by 5, that will be 25 plus 12, which is 37. 37 upon 60. So 37 stays down and 60 goes up. 5 can cancel off 60 and make it 12. So you have 12 upon 37. And yeah, that's what the answer for this question is going to be. Let's begin with the next question. A diagnostic test has a probability of 0.95 of giving a positive result when applied to a person suffering from a certain disease. So if a person is suffering and he gets a test done, then the test has a 95% possibility of showing a positive result, but a 5% possibility of showing a negative result. And it has a possibility of showing 0.1 for, 0.1 is the probability of showing a positive result when the person is a non-sufferer. So if I am not suffering from the disease and I get a test done, then there are 10% chances, there is a probability of 0.1 that the test will be positive, and 0.90% that it will show me a negative result. It is estimated that 0.5% of the population are sufferers. So the entire 100% population, out of it 0.5% are suffering from the disease. Suppose that the test is now administered to a person about whom we have no relevant information relating to the disease. So it's just a random person selected and the test is conducted. It is known that the person is coming from the same very population. You need to calculate two probabilities. It is given that the test is positive. Now, given that the test is positive, what is the probability that the person is a sufferer? And second, if the test is negative, then what is the probability that the person in reality is a non-sufferer? Interpret the entire information of the question first. 0.5% of the population are sufferers. So probability of a person selected at random suffering from the disease will be 0.5 divided by 100, which is 0.005. So probability of a non-sufferer, let's call it P of S complement, that will be 0.995. Okay. Now the test is, see, for example, if I am a sufferer, and I go for testing, then as per this statement, if I am a sufferer and I go for the test, there is a 95% possibility it will show positive, but a 5% possibility that it will show negative. That means probability of positive given suffering is 0.95, but probability of negative given suffering is 0.05. In a similar way, as per the second condition that they have given here, a 0.1 probability of giving a false positive result when applied to a non-sufferer. Means if I am a non-sufferer and I go for the test, the probability that it will show positive will be 10%. So P of positive given that I am not suffering, that will be 0.10. And P of negative given that I am not suffering, okay, not suffering means S complement, okay. N means negative and S complement means not suffering. So P of P given S complement, that is positive given a non-sufferer, and negative given a non-sufferer is 0.9. Positive given non-sufferer 0.1, negative given non-sufferer 0.9. This is the entire information we have taken from the question. Now they are asking us calculate the probability that given a positive result, the person is a sufferer. So it is given that the test is positive. You have to find the probability of person being a sufferer. So you are finding the probability of sufferer given a positive test. So this is P of S intersection P upon P of P. Again, we write the numerator in terms of reverse of this. That is, we write it as P of P given S. There's an unwanted P of S in the denominator of this term. So we eliminate it by multiplying with P of S. The denominator is P of P. P of P means P of positive. In how many ways can you get a positive test? The positive test can be obtained if the person is a sufferer, or it can be obtained with the person being a non-sufferer. So you can write P of P as P of P intersection S and P intersection S complement. P of P intersection S written as P of P given S. Multiply with P of S to eliminate that unwanted denominator of this term. And P of P intersection S complement written again as P of P given S complement into P of S complement. So this will be P of P given S. We need to check the values now. P of P given S, that's 0.95 into P of S, and that is 0.995. The whole thing divided by P of P given S, which is 0.95 into P of S, which is 0.995, plus P of P given S complement, that is P of P given S complement 0.1 into P of S complement being 0.005. Okay. Okay, multiplying these numbers is going to be a task for us now, but it's okay, let's do it. Let's multiply the numerator and denominator with 10 power 5. So we will first have 95 into 995 divided by 95 into 995 plus 10 into 5. Let's cancel off a 5 first. If we divide the numerator and denominator with 5, this becomes 1. 995 divided by 5, so that will be 199, and even this will become 199. You can still divide the numerator and denominator with 5. This becomes 19, this becomes 19, and this becomes 2. So okay, we can evaluate the answer now. So 199 into 19, 200 into 19, that will be 3800, and 3800 minus 19, so that's going to give you 3781 in the numerator, and 3781 plus 2, that is 3783 in the denominator. Okay, so that's the answer for your first question, that P of S given P, that is P of probability of the person being a sufferer given a positive result, that's almost 100% probability, because this number will be something like 0.99 something something. So 3781 upon 3783 is the final evaluation of final answer for part A. For part B, let's go ahead with that. Given a negative result, the person is a non-sufferer. So P of a non-sufferer given a non-sufferer means S complement, given a negative result. So P of S complement given N, calculate that in a similar way. Let's be a little quick. P of S complement intersection N upon P of N. P of S complement intersection N, that is reverse of this. So P of N intersection S complement into P of S complement. In how many ways can you get a negative result? That is P of N intersection S. A negative result can be obtained if the person is a sufferer or if the person is a non-sufferer. So N intersection S complement. N intersection S written as P of N given S into P of S. This will be N given S complement into P of S complement. Try to put in all the numbers now. P of N given S complement, that's 0.9. P P of S complement, which is 0.995, the whole divided by N given as 0.05 into P of S, that is 0.005, plus P of N given as complement and P of S complement are the numbers here only. So 0.9 into 0.995. Again, multiply the numerator and denominator with 10,000. So that will be 90, not 10,000, 10 power 5, which is 1 lakh. So into 995, the whole divided by 5 into 5 plus 9 into 90 into 995. Divide initially with a 5. So this term gets cancelled. You get a 199 here and a 199 here. And divide throughout with 5. So this will be 1. This will be 18. 18 here. 18 into 200. That will be 3600 minus 18. So that will be 3582. 3582. So we have 3582 in the numerator divided by 3583 in the denominator. So the answer for your second question, that is probability of the person being a non-sufferer with a negative result. So given that it is a negative result, the probability of a person being a non-sufferer, that is S complement, the probability will be this, that is 3582 upon 3583, almost a number which is equal to 1. So the probability is almost 100%. Going ahead with the next question. A doctor is called to see a sick child. The doctor has prior information that 80% of the sick children in that area have flu, while the other 20% are sick with measles. Okay. Assume that there is no other disease in that area. A well-known symptom of measles is a rash. Okay. From the past records, it is known that chances of having rashes, given that the sick child is suffering from measles, is 0.95. However, occasionally children with flu also develop a rash with a probability of 0.08. Upon examining a child, the doctor is finding a rash. What is the probability that the child is suffering from measles? Easy question, exactly like the things that you have done earlier. Let's begin interpreting the question. So 80% have flu and 20% have measles. So P of F is 0.8. P of M is 0.2. They have said that in measles, the probability of developing a rash is 0.95. They have said that here. Okay. So probability of a rash, given that it is measles, that will be 0.95. And probability of getting a rash, given that it is flu. So they have said that occasionally children with flu also develop rash with a probability of 0.08. So probability of rash, given that it is flu, is 0.08. Now they have said that the doctor has already examined the child and he sees a rash. Okay, so the rash is seen. It is given that the rash is present. Now what is the probability that it is measles? So they are asking you the probability of measles given that a rash has already been observed. So we write the numerator as reverse of this. P of R given M into P of M. As per definition, the denominator will be P of rash, P of R. P of R is going to be P of, how can you get a rash? You can get a rash with measles, or you can get a rash with flu. P of R given M, R intersection M, written as P of R given M into P of M. Plus you have P of R intersection F, written as P of R given F into P of F. Okay. So P of R given M, that is 0.95 into P of M, which is 0.2, divided by P of R given M and P of M, which are 0.95 and 0.2, plus P of R given F, that is 0.08, into P of F, which is 0.8. Okay. If you just multiply the numerator and denominator, or let's divide the numerator and denominator with 0.2. So this becomes 1, this becomes 1. And 0.8 upon 0.2, it's like 8 upon 2. 8 upon 2 will be 4 and 0.08 into 4 will be 0.32. Plus 0.32. So this is going to be if you multiply the numerator and denominator with 100, it will be 95 upon 95 plus 32. That will be 127. Yeah, so that is P of M given R. That is the probability that the child is having measles given that he already has a rash. That probability is 95 upon 127. Yeah, that's how we are answering this question. And with that, we go ahead with our next question. Again, it's a similar question. These questions are all of the same type. 2% of the population having a certain blood disease of a serious form, 10% have it in a mild form, and 88% do not have it at all. A new blood test has been developed. The probability of testing positive is 9 by 10 if the subject has the serious form, 6 by 10 for the mild form. That will the test will test the person positive with a probability of 1 by 10 if he doesn't have the disease at all. So even if he doesn't have the disease, he will be tested positive with a probability of 1 by 10. A subject is tested positive. What is the probability that the subject has the serious form of the disease? Interpret all the things in this question now. So you have probability of the serious form as 0.02 because 2% of the population has the serious form. Probability of having the mild form is 10%, so 0.10, and probability of not having the disease, that is P of N, is 0.88. Probability of testing positive given the serious form, that is 0.9. Probability of getting tested positive with a mild form is 0.6, and probability of getting tested positive with not being diseased is 10%, so 0.1. Now they are asking you, see, they have already told you that the subject has been tested positive. Now what is the probability that he has the serious form? So you have to find the probability of serious form given that he is tested positive. So what we do is we write the reverse of this. That will be P of P given S into the unwanted denominator, which is P of S, divided by the denominator for this is P of P. How can a person get tested positive? He can get tested positive if he has the serious form, or if he has the mild form, or if he has or if he does not have the disease. In all these three cases, he can get tested as positive. So P of P intersection S, write it as P of P given S into P of S. Then P of P given M into P of M. Similarly, the last term, which is P of P intersection N into P of P given N into P of N. So now P of P given S into P of S, that is 0.9 into 0.02, divided by the denominator contains 0.9 into 0.02 as your first two numbers, plus P of P given M into P of M, that is 0.6 into 0.10, plus P of P given N, that is 0.1 into 0.88. So if we multiply the numerator and denominator with 10, this 0.9 first becomes 9, this becomes 9, and this 0.1 becomes 1. Let this remain as 0.88. The term here also becomes equal to 6, and then you multiply with 100, so this becomes into 2. This is also into 2. This is into 10, 6 into 10, let's write it directly as 60, and this becomes 88. Okay, so in the numerator you got 18, in the denominator you got 18 again. Divide with 2 throughout, so this is 9, this is 9, 30 and 44. Yeah, I think we are done with the addition part or the division part. We just need to add up these numbers now. So this is 40, 30, 70, 74 and 83. Yeah, so 9 by 83 is the required probability, and that's how we are answering this question. We go ahead with the next one. A box contains 3 coins, 2 fair coins and 1 fake 2-headed coin is picked up randomly from the box and you are tossing it. What is the probability that it lands heads up? So first of all, what is the probability of selecting a fair coin? Probability of a fair coin getting selected will be 2 by 3. That's because there are 3 coins, 2 of them are fair coins and 1 is a fake coin. So what is the probability of a fake coin getting selected? So probability of the fake coin coming is 1 by 3. This F stands for fair. So P of fair 2 by 3, P of fake 1 by 3. What is probability of getting a head given that it is a fair coin? See, given that it is a fair coin, probability of getting a head will be half. But if it is a fake coin, then probability of head given that it is a fake coin, that fake coin has heads on both the sides. Okay, so probability of getting a head given that fake coin, that probability will be 1. What is the probability that it lands heads up? So you have selected at random some coin, you don't know what coin you have taken, you just need the probability of a head turning up. So probability of a head turning up will be, this will be probability of a head turning up along with a fake coin, that is P of H intersection F, or probability of head turning up given that, probability of a head turning up with the fake coin. So P of H intersection F or P of H intersection fake is going to be the total probability of getting a head. So this will be P of, we can write this H intersection F as H given F into P of F, plus this can be written as P of H given fake into P of fake. P of H given F, that's half. So you got half into P of F, that's 2 by 3. Plus this term is 1 into P of fake, which is 1 by 3. So this gives us 1 by 3 plus 1 by 3, which is 2 by 3 as P of H. And finally they are asking us if it, we just got it as 2 by 3, okay? If it happens to be a head, so they are telling us already that it is a head, okay? What is the probability that it is the two-headed coin? So they are already telling us that it is a head. You have to find the probability of it being the fake coin. So find the probability of it being a fake coin given that a head turns up. So this will be P of fake intersection H divided by P of H. P of H we don't have to calculate it separately, we have calculated it over here. Okay, and in the numerator you will have P of fake intersection H written as P of H intersection fake. Basically you need to write the reverse of this. So P of H intersection fake into P of fake divided by P of H. So in the numerator you have P of H given fake, which is 1, multiplied by P of fake, which is 1 by 3, divided by P of H, which is 2 by 3. P of H and P of H we just got as 2 by 3. So the denominator is what we are writing as 2 by 3. Cancel off the 3 and you have 1 by 2. That's the final answer for your B part. Okay. So if you realize, it's again the same very question. And with that we go ahead with the next question, which is again a similar type. Similar in the sense literally the same type of question. Three social media groups, 1, 2 and 3. The probabilities that group 1, 2 and 3 are sending messages on sports are 2 by 5, 1 by 2 and 2 by 3. The probability of opening the messages by group 1, group 2 and group 3 are 1 by 2, 1 by 4 and 1 by 4 respectively. Randomly one of the messages is opened and found to be a message on sports. What is the probability that the message was from group 3? So the probability of posting a message by group 1 is 2 by 5. Probability of posting by group 2 is 1 by 2. Probability of posting by group 3 is 2 by 3. They are now telling you that probability of opening a message given that it is group 1. The messages sent by group 1, if they are opened, the probability is 1 by 2. So probability of openings given that it is sent by group 1, this is 1 by 2. Probability of the message getting opened given that it is sent by group 2, that will be 1 by 4. And probability of message getting opened given that it is sent by group 3, this is also 1 by 4. They are asking you randomly one of the messages opened. So the message is already opened. Okay, they have said that it is already opened. Now what is the probability that the message is from group 3? So you are finding P of 3 given that the message is opened. Okay, So we write the numerator as P of 3 intersection O upon P of O. But that P of 3 intersection O, when you write it in the reverse form of this, it will be P of O intersection 3. But you need to eliminate that P of 3 in the denominator of this term. So you will eliminate it by multiplying it with P of 3. The denominator will be P of O. P of the message getting opened, that will be P of O intersection 1 plus P of O intersection 2 plus P of O intersection 3. That will be P of O given 1 into P of 1 plus P of O given 2 into P of 2 plus P of O given 3 into P of 3. Okay, so we continue writing those numbers but on a new page. So P of 3 given O, that will be the numerator containing P of O given 3 into P of 3, that's 1 by 4 into 2 by 3. So we get 1 by 4 into 2 by 3. Let's look out for other numbers in the denominator. P of O given 1 into P of 1. So 1 by 2 into 2 by 5. Plus P of O given 2 into P of 2. So 1 by 4 into 1 by 2. And the last number is very much what you have in the numerator. That's 1 by 4 into 2 by 3. So if you simplify that, you get in the numerator it is 1 by 6, the whole divided by this will be 1 by 5 plus this will be 1 upon 8 plus this will be again 1 upon 6 only. So 8, 6 and 5, the LCM, it's 40, 80, it's 120 only. So if I take the LCM as 120, let's multiply the numerator and denominator with 120. So in the numerator you get 20 and in the denominator 120 by 5, that would be 24 plus 120 upon 8, that would be 15 and 120 upon 6 would be 20. That's 44 and 59. Yeah, so 20 upon 59 is the required probability and 59 it is. Okay, and yeah, that's how you are answering this particular question. That is, if one of the messages has been opened and found to be on sports, the probability that it was sent by group 3, that probability is what we got as 20 by 59. Okay, let's move on with the next question. They have given this question in the textbook as activity. There's nothing like activity here. It's just a simple question based on the Bayes theorem that you need to solve. Mr. X goes to office by auto, car and train. The probability is that he will go by auto is 2 by 7, car 3 by 7, train 2 by 7. Let's write the information quickly. P of auto, P of A 2 by 7, P of car 3 by 7 and P of train is 2 by 7 again. The chances of him being late for the office are 1 by 2, 1 by 4 and 1 by 4 by auto, car and train. So probability that he is late given that he is traveling by auto, it's half. Probability of being late given that he is traveling by car is 1 by 4 and probability of being late given that he is traveling by train is 1 by 4. Now one particular day he is late to the office. It is given that he is already late. Now find the probability that he was traveling by car. So you are finding the probability of car travel given that the person is late. This will be written as the reverse of this. So P of L given C. Eliminate the unwanted denominator with P of C. And in the denominator you will have P of L because given L. So denominator is P of L. How can he get late? He can get late by traveling with car, or he can get late with traveling by auto, or he can get late by traveling by train. Okay, P of L given C written as P of L intersection C written as P of L given C into P of C plus P of A intersection C written as P of L intersection A written as P of L given A into P of A. And then we have P of L given T written as P of L intersection T written as P of L given T into P of T. Okay, substitute all these numbers. P of L given C into P of C. That's 1 by 4 into 3 by 7 divided by, it's the same numbers at the start, 1 by 4, 3 by 7 plus L given A into P of A, so that's 2 by 7 into 1 by 2 plus P of L given T into P of T, that's 2 by 7 into 1 by 4. Let's multiply first the entire numerator and denominator with 7. So this 7 is just going to go off. This 7 gets cancelled. This 7 gets cancelled here. And this 7 gets cancelled here. This number here is P of A. So this number is 1 by 2, okay? Let's multiply the numerator and denominator with 4 also. So this 4 gets cancelled and finally we are left with a 3 in the numerator. Multiply this with 4, so you are left with a 3 here, plus multiply this with 4, so that will give you 2 into 2, which is equal to 4 only. This is a 4 here, plus multiply this number with 4, so you are left with simply a 2. So the final probability is 3 upon 9, which is equal to 1 upon 3. So yeah, the required probability here is 1 upon 3. That is the probability that the person, so given that the person is late, the probability that the person was traveling by car, that probability is 1 by 3. Let's now go for the last two questions that I was talking about. I felt they are a little bit out of context or not related to the previous type of questions that we have done. But yeah, somewhat they are probability questions only. So let's solve these two questions also. They have said E1 and E2 are equally likely to occur. So P of E1 is equal to P of E2. They are mutually exclusive, means there is no intersection between them, and they are exhaustive. Exhaustive means the total of E1 and E2 is going to form the entire sample space. With these two, with this information, we conclude that P of E1 and P of E2 will be equal to half. Because if you think a little bit over the given case, if this is your sample space, okay, then you don't write E1 and E2 in this manner. First of all, there is no intersection between them, so you need to mark them like this. But the total of E1 and E2 has to give you the sample space. So we are making E1 and E2 like this event being E1 and this entire event being E2. So this entirely is E1 and this is E2. So if you check that Venn diagram, it's like E1 and E2 are total, making your sample space, and there is no intersection between them. So that is how we are interpreting the condition of mutually exclusive and exhaustive events. And because they are equally likely to occur, we said that their probabilities are equal to half. Okay. Now they have said P of A given E1 is something, P of A given E2 is something. Find P of E1 given A. So like you've been solving your previous questions, the working will happen in a similar way. Write the reverse of this. This will be P of A given E1 into, you will say, P of E1 divided by, it should be P of A in the denominator. How can you get the event A to occur? Either the event A will occur along with E1 or the event A will occur along with E2. To write that P of A intersection E1, write it as P of A given E1 into P of E1. Similarly, the other part, P of A intersection E2 will be written as P of A given E2 into P of E2. Now P of E1 and P of E2 are all equal to half. Take that half common from the denominator, cancel it with the half in the numerator. So all these terms are going to vanish. And you finally have three terms left with you. So P of A given E1, that's given in the question as 0.2. So we have 0.2 upon 0.2 plus P of A given E2, which is 0.3. So that's like 2 upon 2 plus 3, which is equal to 2 by 5. And that's the final answer for this. I think it's the fourth question. Irrespective of whatever the number is, that's how we are solving and getting the answer for this question. And finally, the very first question of that exercise, it's right here. It's not really related to Bayes theorem, but okay, somehow it may be related to Bayes theorem, but you can solve it in a straightforward manner. There are 3 bags each containing 100 marbles. So bag 1, bag 2 and bag 3. Bag 1, 75 red and 25 blue. 75 red, 25 blue. Bag 2, 60 red, 40 blue. Bag 3, 45 red and 55 blue. One of the bags has been selected at random and a marble is chosen from the bag. The probability that the marble is a red marble. So you're finding probability of a red marble to be selected. You can have that red marble with either box 1, or you can have it either with box 2, or you can have it either with box 3. I mean, either you can have it with box 1 or with 2 or with 3. Okay, so we are writing P of R intersection 1 as P of R given 1 into P of 1, P of R given 2 into P of 2, plus P of R given 3 into P of 3. R given 1. Given that you are selecting box 1, P of R is 75 upon 100, which is 3 by 4. And probability of box 1 to be selected is 1 by 3. If there are 3 boxes, the probability of any one box to be selected 1 by 3. P of R given 2. Given that you are selecting the second box, probability of getting a red ball, that will be 60 by 100. So that's 6 by 10, or you can call it 6 by 10, right? So 3 by 5 into P of 2 being 1 by 3. Similarly, P of R given 3. From the third box, the probability of selecting a red ball, 45 upon 100, which is going to be what, 9 by 20 into 1 by 3. I think we should keep the denominators as 20, as that's the LCM. So 3 by 5 being written as 12 by 20 and 3 by 4 being written as 15 by 20. Okay, 1 by 3 can come out common. 15 plus 12 plus 9, that's 36 upon 20. 3 and 36 get cancelled, giving you 12. 12 upon 20 will be 3 by 5. And yeah, that's the final answer for your first question. So that's where we are done with discussing all the questions that I wanted to discuss in this video. I hope that the contents of this video have been someplace somewhere helpful to you in your preparations. Thank you for watching.